Okay, so hello.
Hello.
Today we're starting part two of the book, and we're gonna talk about language size. And the first thing that I should do is ask you, what are your feelings about this chapter, Marin?
Ah,
Because we debated these ourselves already.
well, the core of the language should ideally be small, but if it has a very large library, I'm not complaining.
But that's the thing. Actually, that's kind of like the core thing. Should it? Because at the point that you are baking the libraries and making like a standard to use it as long as with the core, is it the language really that small then?
No, 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 no. It's not that the. Well, ideally, the language shouldn't force you to use the standard library, because that would be kind of silly if you're trying to keep the core small.
Well, I think the book is showing that it is not silly actually. I think that's the whole point. That this debate is kind of like less trivial than we might expect. That we don't really have very strong evidence of either side.
Hmm.
And actually, that's the
Personal.
conclusion of this.
hmm, Well, personally, I like Zig's approach. Actually, it has a standard library. Most people use it, but you can actually ignore it if you want.
Well, okay, but let's start. So the theme of the conversation is about the size of the language, and we're gonna also discover that the boundaries between the core of the language and the libraries are not is not that definitive. de- Definitive. It's kind of like a blurry line,
Very
and
blurry.
and the book starts by talking using common lists as the example, uh, which is very interesting. So I was not aware of this, but apparently there was a Lisp battle back in the day.
Well, there was. That's the whole point of Common Lisp, actually. There were so many dialects that they were like, yeah, let's make a Common Lisp that tries to unify the features of all the currently existing dialects in a way that kind of makes sense. And,
Yeah, but I didn't know there
eh,
were two main like competitors that then generated the subdialects that then culminated in Common Lisp. I didn't know that part.
yeah, it's kind of a very messy story. And there's also Scheme somewhere in the middle there. Scheme actually predates Common Lisp, believe it or not.
Yeah, it's also interesting to see this sentence. I think this sentence is interesting. Like, okay, I guess I learned something today. But anyway, so there was a battle between two main Lisp dialects called Interlisp and MacLisp. Apparently, the MacLisp generated many subdialects. And then they decided to get a different description of a family of languages called Common Lisp. And it was relatively straightforward in the beginning, but then it came the ANSI Common Lisp standard that blew things up out of proportion. Then they added the clause, which is the object system. Um, that took 8 years, apparently, this process.
Yep.
And there's also the fact, which is my critique to this chapter, because I think aside from the very end of everything, Gabriel again is putting everything in a static analysis kind of thing. So everything that he's talking about is true with the assumption that everyone is static for the entire process holding. So if people are the same as they were in the beginning, they don't learn, they don't improve, everything holds. The moment that you put movement and people start changing and changing their opinions and learning stuff, I think it's complicated to assess everything, because at some point in time in my life I thought C was a big language. And then after that, I thought Haskell was a big language. And now those definitions for each of those languages changed after I learned more stuff. And I think that that is makes it all of these analysis very complicated. Maybe that's the reason that he made decided to do statically.
Hmm.
So um, anyway, so then there was the AI stuff that apparently people were using Common Lisp for that in the beginning of times, but then they ditched that to C/C++. And as he pointed out, that was not a 100% nonsensical decision, but rather because it's cheaper and easier to find C and C++ people than Lisp people, which again is kind of like the worse is better thing. Which, by the way, this book came after the worse is better.
Yeah, worse is better is actually cited in one of the later chapters.
Yeah, so it's 1991 and this is 1996. So because he gave us hints of that in here, and I was kind of thinking who came first. So the article came first. And then the problem size is what he wants to address, and he asks someone about that particular problem, and he said, there is a basic tension between small, elegant languages and large, efficient languages. The reason for efficient languages being large is that typically the price for efficiency is specificity. So in order to have a general purpose efficient language, the number of constructs must grow. Nekoma,
That's
go on.
kind of a weird take, okay. Because, like, C is not actually that large. It's actually pretty small. C++ is huge, granted, but C itself is kind of small, and yet it's like the most efficient language that people have today.
Um, I agree with what you said, but I think he's talking about a different, like, the reason that C doesn't suffer from this efficiency problem is because everything it's not very high up, right? So like if you're working with a very high, let's imagine that we have the power to make an hypothetical language. In that particular language, there we have multiple data structures that are like completely abstracted out, and you have different strategies to allocate memory for each particular data structure. And I'm not gonna put examples because I'm not very familiar with that, but you're gonna have to specify like, okay, for this particular tree, this memory allocation is better. For an array, this is better. For this is better. So if you remove all of that stuff, all of the fanciness, and just go to plain malloc, then sure. But I think this person was more like talking about like if you increase the level, efficiency starts to become a problem.
It does, but it does not follow that to make the language more efficient while keeping it high level, you have to make it larger.
Repeat, please.
Like, it doesn't follow that for a high level language to be efficient, it has to be large.
Which example do you have?
Uh, well, chess scheme is actually pretty fast, and it's a scheme.
Well, I guess it depends on the definition of the size because that's one of the things we're going to talk about. One of the things that I personally have with the whole Lisp vibe of like, okay, we have very few built-ins, so everything is kind of the same thing. He's going to talk about this with the basic English. That although sounds like a good thing in the beginning, that you have very small core,
But
starts to get annoying pretty quickly.
but the point is that you can abstract over the core, right?
It doesn't matter. If you abstract that to a function or a macro, and you want to know what happens under the hood, you're gonna have to go to definition anyway. Doesn't really matter. So
But
uh,
the whole point of abstraction is trying to get away from the details.
I'm not saying it's not. Um, I'm not saying it's a worse, like the worst of the worst. I'm just saying that my main problem with this argument, which is that sounds good in paper, but actually using it, it's at least in my experience, it's a pain in the fucking butt. At least this is mentioned in here, which is actually surprising to me because especially talking to you, which is you are more accustomed to Lisp. You never complain about this, and I 100% complained this to you before. I was very glad to see that I'm not the only one. That people understand that if you have very primitive but useful things, but you don't have very many of them, you're gonna incur into the problem of like some stuff is very annoying now. Which, well, it's a trade-off, right? We are making a trade. You either have that, or you have the the bad things of having a large core.
Personally, I think the way to think about it is okay. Do you have good data structures at the base? If you do, like most things are easy. Like if you have efficient lists where you have random access and you can add stuff to either end and you have slicing and concatenation, which granted most languages don't have that, which is very sad. If you have efficient maps, again, same thing. A lot of languages don't have that, although that one is much more common. And if you have, well, sets you don't really use as often as maps or lists, but
That's
ideally you
actually a
want those.
perfect segue. What is going to be the criteria to add something?
Uh, well, there are basically four main data structures if you try to get down to it, although maps are kind of weird. Let's ignore maps for a second, okay? There are basically four kinds of data structures. You have lists, which are sequential, and you can have repeated stuff in the list. You have sets, which are the opposite. There's no order between the elements, and you can only have one of each. And then you have multisets and ordered sets. Those are not very common, uh, which is kind of sad. They should be. Multiset is okay, there's no ordering, but you can have repeats, and ordered sets is there's no repetition, but there's order. And that
Mm-hmm.
basically covers all the things you can have on a data structure. Although I say maps are weird because these four kinds of data structures, they're not really like, they're not associative. You have stuff in them, but you don't really have a key to look stuff up. If you add maps onto that, then you have like basically five kinds of data structures.
Well, but you didn't answer the question. You said examples of what I think would be great candidates for data structures to be in the core, but you didn't explain the criteria.
The criteria is okay, what are the fundamental ways you can organize data?
Hmm. Okay, that's a valid response, I would say. Although another proposal criteria that Gabriel proposes is actually the commonality on using them. So he uses the example of multidimensional arrays that scheme doesn't have, and the argument is that arrays are for arrays that programming with them is so common it should be supported. And the argument against is that you could roll your own arrays using vectors of vectors, and the only difference would be speed. Therefore, because multidimensional arrays can be expressed in terms of other primitive constructs, scheme would be less elegant by admitting redundant constructs.
Vectors of vectors is such a terrible way to implement an array though.
Now, I guess it depends how you're implementing vectors, no?
Well, vectors in Scheme, they have to be implemented a particular way because of the performance characteristics mandated by the standard.
Ah, okay,
They
I
are
didn't know
basically
that.
a flat array
Yeah.
of fixed size.
That is, to the scheme community, adding multidimensional arrays would decrease the elegancy of the language because it's just redundancy.
Well, if I were to implement multidimensional arrays in Scheme, I would define a record type that contains an array and just has the size of each dimension of the array and the array itself, well, the vector, I should say. And it basically just does the math to say, okay, the normal multiplication you have to do when you're doing indexing into a multidimensional array, that stuff.
Yeah, no, that's cool. I 100% believe you would make a great implementation, but the question is, would that implementation be part of the core?
Uh,
Because
I would be,
the dilemma here is usability and convenience against elegancy and redundancy.
I would be tempted to say yes, actually, but not for the reason you may think.
Well, that's not my reasoning. It's the reasoning proposed in here. So the argument goes two ways. If it's common and everybody's using it, it should be in core. It should be supported. But the other side of the argument is saying you can implement that yourself. You're a lazy boy. Just go do that.
Well, my counter argument to both sides is, dudes, mathematics. We do array operations in mathematics.
That's a bad
We are.
argument. They're gonna hate you
Why?
because, as we are going about to see, I don't know if this is in this chapter anymore. Maybe it's in the next one. People don't like that. People don't. Well, again, assuming everyone is static and nobody changes their opinions, the main opinion, the dream that people want to live in, is in a reality in which you don't have to know any method of programming.
That's very bleak.
And I'm not saying that I'm not saying they should think that. I'm telling you the truth. I was there at some point in my life. I was in that group actually, and I remember these conversations about people trying to defend the idea that you don't have to know linear algebra, you don't have to know basically anything resembling mathematics because they just want to do web programming with JavaScript all day.
But
And
programming is a form of mathematics.
but that's the thing. After some point, I changed my mind. So that's what I'm saying. That premise, and again, I don't know if this is in here or it is in the next chapter. Probably it is in the next chapter. Yeah, it is in here. In the next one, I don't know if we're gonna have time to talk about this today. But one of the things that Gabriel said is that if you want your language to survive the natural selection of programming languages, you should not preach for a mathematical sophistication. So, which is kind of like exactly why people the two sides would look at you and hate you because you would be right, but they don't want to know about that. They don't think that's as a plus. And that's a, that
uh,
you may have what are you gonna do then? That's the
well,
problem.
yeah. But anyway, just to conclude my thought, because we have array operations in mathematics, and because addition and numeric stuff is probably primitive, then it follows that if you want to have array operations, and well, basic addition, multiplication, etc., is primitive, then array should also be primitive, no?
Yeah, no, makes
Otherwise, you have a
sense. No,
primitive operation that works on a non-primitive type. That's weird.
no, I agree. I'm again, I'm not saying I'm not in either of those sides because I think well, I can see where they're coming from. I see that yes, if it's common, I think it should be supported, and I also see sense in saying yeah, but that's just redundant. Just like OCaml, for example. We complain a lot about the prelude being crap. Why is that? It's not because we cannot implement it ourselves. It's because it's just annoying, right? Because the language comes with established prelude, and we just want to get something done instead of making a library. Like imagine if you want to make a project using I don't know you're making a game you're gonna have to make a linear algebra library for the language before that's demotivates you, that's more expensive, that's more time consuming, that's more error prone, all things that all those things are cost. So I understand why like this makes sense, this is not irrational. What I just think is that I think there are more variables to the discussion than just simply, okay, uh, com- convenience versus elegancy. I don't know. I don't think that's the those are not the only two people on that table. That's what I'm trying to
I
say.
think I think part of the problem with Common Lisp in particular, actually, is that he mentions that there's not really a distinction between what's part of the core and what's a standard library, right?
Yeah,
I think
he mentions that it is kind of blurry.
I think if you make that distinction a bit more clear, then a lot of this debate kind of goes away because you can say, yeah, okay, this is not part of the core because it would be redundant, but it's so common that it should be part of the standard library. That's a reasonable position, don't you think?
Depends because it depends how you do the distinction between the core and common library. The problem, the blurriness comes from the idea that if core is useless without the common library, is it fair to make that distinction?
No, no, the core is not useless without the common library because the core will be used to define the common library. You see the point?
No, no, no. The usefulness criteria here is like, okay, you can use core to make libraries, but all the application in the world only cares about the libraries. They don't use core there very much. So
But the
if
core is like lambda and stuff.
no, again, I'm not saying it's okay. Let's say it's not 100% useless. I just made the exaggeration just for the sake of the argument. But let's imagine that okay, you use Lambda, that's cool, but everything, all the operations that matter for I don't know game development, are done via OpenGL in the library somewhere. And in that particular case, from the perspective of the developer making the game, your language that you day to day interact with is not core.
Which
Uh,
is totally fine.
it's fine, but for what Gabriel is saying is, what if the majority of common Lispers actually use more of the libraries instead of the core? Then it makes it weird to say that okay, we actually care about the core being small, but nobody uses that in reality.
But the library is defined in terms of the core. Everybody uses the core, just indirectly.
Well, but if you're gonna say that, like if using it in, I don't think the conversation assumes that using indirectly is using it. I think that's a fair point. But the author never mentions this distinction that hey, actually it doesn't really matter the distinction between libraries and core because you cannot use the libraries without using the core. Hence, everybody's using core. It's kind of the same thing as saying you're using a compiled language to x86, so you are using assembly. Come on.
That's not quite the same because you are leaving the realm of the language semantics when you go through the compiler, right?
Yeah, no, but that's just another example of like indirectly using something. I don't think that's in the conversation. I don't think anything about these two chapters uh, that well, this one and the next one, they are considering that indirectly uses using it. Because if so, then there's no point in this discussion. Who cares about the distinction about library and core anymore? If
Well,
indirectly you're using the core.
the people implementing the language certainly care about it.
Well, of course, that's fair. Okay, moving forward, then we talk about complicated like I'm not gonna say overbloated because I think it's very useful. Like I actually think this is kind of phenomenal. I just don't know if I would say it is simple in my particular definition of simplicity. So there are more compelling reasons for efficiency, but if a data structure is commonly used, it should be supported as well as it can be. If a useful and frequently used function is difficult to implement correctly, it should probably be supported. I think that makes sense. And a good example of this is a very complicated in terms of functionality and moving parts function called format, in which it has this ability of like doing English fixes. How do you call this? I don't know how you would call this, but it
Actually,
knows
it's
this is a
actually it's
number and then plural in here.
actually it's worse than that. You can print like Roman numerals in Common Lisp.
Okay, so uh, and again, this is the thing. So you're making a compiler and you want to inform how many warnings and errors you have so far in a program, and this does exactly that. But the ability to do the corner cases instead of just doing this makes it prettier, right? Because this is like conjugating the English correctly and so on. But it's a little bit over the top because there's control flow, there's conditionals, all in a simple printf essentially. And then we have the trade-off. So there is control structure encoded in the format strings. There is syntax obscure syntaxes for strings. Encoding of the format strings is compact, so the complicated instructions don't take up much space. But again, this is not to say it is not useful because it is useful. It is just we go back to the idea of like, okay, wasn't this supposed to be simple? What are we doing? Um, so
Yeah.
um, format strings don't look like Lisp, so you are actually making a DSLL inside your programming language in a way.
A string-based DSL, which is kind of sad.
Oh, of course. Uh, so then this is the main thing, and it uses this thing to do the stop conditions. Um, it is unlikely that people will implement format on their own. It is almost equally unlikely that people will bother writing the code to produce nice, readable diagnostics. But instead, you just do this, which is well less not cool, but still useful. Um, um, but then, well, anyway, that's another point to this conversation. And there is one of the commenters here. This is kind of saying, it's kind of making an implication of a relationship between small and elegant. But now we're gonna go to another quote, which is that it's easier to reason about an algorithm expressed in a small language because the primitives of a small language have simpler, more intelligible, and often better defined semantics. So it's easier to show that algorithms expressed satisfy the specifications and to analyze their complexity. I think this is something I've seen. I'm in a video from Jonathan Blow, I think last week or 2 weeks ago, where he was talking about uh, the idea of having a smaller subset of expressive stuff, allowing you thus to make more stronger assertions about such subset, is interesting to him. So it's kind of like the opposite of like you have all the power, you have very little, well, not little, but restricted amount of power, and because it's so restricted, you can have strong assertions about its properties. And I don't
Uh,
think this is the exactly the direction this person is talking about, but I think it's related.
it is related, and in fact, some, not all, but some scheme compilers actually do something similar to this, where they say, okay, compiling full scheme is difficult, but we can compile scheme to a slightly more restricted dialect of scheme that uses fewer features. And then you can compile that to an even smaller dialect that has even fewer features. And you keep doing that until you reach something that is scheme-like in how it looks like, because it still has expressions and it's valid scheme, but it actually looks very similar to machine language. So you can just translate that very easily.
Yeah, and there is that benefit as well. If you have a smaller set to work with from the start, you have some benefits such as like it's more dedicated optimizations because you can have more assertions. You can have better mapping between the machine language and the high level language. All that stuff. Of course, this doesn't come for free because having a smaller subset of possible things to conveniently do means that it's less convenient. So that's one thing. And that's what we're going to talk about next part because it's saying the difficulty of a proof of correctness, though, is at least partially dependent on the size of the text. In a small language, text is large because either things are spelled out in place or there are auxiliary functions or programs. In either event, the proof of correctness will likely have lemmas corresponding to chunks of the program text, and these chunks will be equivalent to the constructs you'll find in a large language. So I don't think proofs would be substantially easier based on the size considerations alone. And I agree, but I think Gabriel missed, and I don't know if this is a anachronism thing that I'm doing here. If you have more text, but they are the same, you can more easily mechanically verify them. So I don't know if he was considering that, if at the time that was not a thing, uh, because I think that's something that you can get around. Like in terms of human readability, yes, it's more text and that's a problem. But if you have like a proof assistant working alongside you, having more text is whatever. Um, any difference would be because one language might have formal semantics, whether another might not. A small language defined by a group of mathematicians might have usable formal semantics, and people who wish to prove correctness would be lucky with such a language. But, and this is not news for anyone, I've been in the industry for over 10 years, and I don't see a lot of people proving correctness. I see them reasoning about their programs, but they don't need a formal semantics to do that. And I think that's the beginning of the disliking of math related sophistication, quote unquote, that we're going to see in next chapter. So here's where that this starts, and well, this is not news. We know that. Informal reasoning about a program is a complex language construct, however, can be difficult only when only a small portion of the construct is used in a particular case. That's actually a very good counter argument because this is basically establishing that if you have something large and who knows how much of it will be useful, you can have more than you need.
Yeah, like formats and the whole syntax for format strings in Common Lisp.
And this is a very complex sentence, but I think I got it. It's a matter of conjecture whether it's easier to prove the correctness of a reduce use of functionality than to code and prove correct your own reduced version of it. So he's basically saying that it's basically a guess to say that it's easier to prove the correctness of something large being reduced or a small portion of something large read in comparison to you coding and proving your own by hand reduced version of it. So that's a very strong statement. Then we're going to go to the same person making another remark. The conclusion one reaches by reasoning about an algorithm expressed in a small language are more likely to apply to actual computer executions of the algorithm because a small language is more likely to be corrected implemented in a computer. I think that's a little bit also strong because this relationship is now we started with this small being related to elegant, and now we are going even further and saying that small is related to correct. So very strong statement. And now this is bad news for libraries. If you can't trust the implementers of a language to implement correctly something well specified in a standards document, how can you trust a library implementer? Indeed, since we know that the language implementers discouragingly often get it wrong. But the key here is how to get the correct program in the face of its size and its piecemeal origins. How can we retain a correct program as it evolves? Because this is very expensive, right? So as you are putting more stuff on it, and I actually use this argument in my master's, um, my stuff, my master's was done via verification via simulation, because I was not proving that from each layer that I was adding on top of it, I was like reproving all the properties and reassuring that they are still there, and I didn't break anything when I was adding more stuff to it, which is a very like a weaker type of verification via simulation. Uh, but then the real question becomes, okay, how can we do it properly, but keep it up as it evolves? And my understanding is that this is very hard and expensive to do. Um, it's easier and quicker to learn a small language. And then there is some heuristics about how much time you should take to learn a new language, and your first one for that matter. So 13 to 14 weeks to learn your first, 4 to 8 working days of 8 to 12 hours each for any subsequent one. Um, and there is some appendix to that rule. But I also think this is problematic statement, which is to say, if a company hires a new bachelor's in computer science of average ability and throws a new programming language at him, and after a month he's still not using the resources of that language effectively, then probably the language is too big.
Ah, the
There are
problem.
at least two problems with this sentence.
I don't really trust the average ability of any particularly large group of people for anything.
That's the first. Who said that the average is on a good place? And then there's the second, which is who said that the company is allowing people to best utilize the tech they chose?
Yeah, I have a few examples that come to mind, which I shall not share here because this is being recorded.
Yeah, but you know exactly what I mean. You know exactly what
Yeah,
I'm talking about. So they are like, you're not blaming the company and you're not blaming the average. If those two things are out of the window, then I kinda like I kinda can see, because there is actually a third problem, which is, what if the average also is not, well, that kind of goes back to the first argument of the average being bad, but what if the people are too arrogant to consider that there may be something better? Like, maybe they are putting a barrier on to themselves to make it, and that is making it harder to learn the new stuff. And then you're gonna blame the new stuff being too big because of that, given this heuristic. So I also think that's a problem, like pride and social stuff and all of that. I also think this is part of the equation with this type of stuff. If those three premises are off, so the company can't be blamed, the average is great, and people are not uh, prideful and arrogant, then in this very unlikely to be world, yes, maybe.
maybe.
Uh, but then, well, then we go back to the habitability the argument, because this, how much time it takes for you to get used to something, is 100% related to how habitable something is. Uh, and then we're gonna go. This is a very good argument, which is, I don't think there is a difference between learning something and mastering something. And learning something is not clearly defined, but reading the context kind of implies that learning is getting shit done, and mastering is getting
Being good
shit
at it.
done the way that the tool was built for it,
That's a
which
good definition.
which implies being good at it. Because in the beginning of times, Fortran people were just rewriting Fortran in a different syntax when they were trying to do scheme. But is that really the way? And then that this distinction comes along, which I think it's spot on, because it's very easy actually, especially with nowadays tooling, to just grab the way that you are used to do something and just change the syntax to something else.
Yeah, I can think of a couple examples of that. There's one in particular, again, I'm not sharing here because recording,
Yeah.
where it's like, okay, this certainly looks like Clojure. It's a CLJ file. It runs if you give it to the Clojure compiler, but this feels like Java.
Yes, exactly. You use a programming language to communicate with both a computer and also to people. The people who will maintain and go and alter your code after the original authors no longer maintain it. Because of this, the code you write must communicate well using familiar idioms or in patterns of use. And again, this is also a problem in the scale of a company. If everyone working at a company does Clojure as Java, and you do Clojure properly there, you're gonna get negative feedback, because that's not how people are used to communicating. That's not a familiar idiom for them when communicating via code.
Yeah, it's kind of sad.
And this is not only learned by years of experience, but also the place that you are currently in. Like it's basically an onion with a bunch of layers, and one of the layers is experience and like how to be good at using a particular tool, but also the environment that you're currently in. Because if people are just hating the tool and they have to maintain it because it's impossible to rewrite it in something else, they will have very strong opinions about how to use the tool, and a lot of the time that's not how to use the tool properly. Um, and this is true that mastery takes a long time. Then the real question becomes whether the time for mastery differs from small and large languages, which is a very fair next follow-up question. If the small language is augmented by libraries, there will be no difference between large and small. And if you need to reinvent or acquire idioms to make writing your code faster and using a small language, then probably be no difference either. Only if the language is illogical or so poorly designed and so syntactically obscure that it hinders common sense will the language itself be the higher order bit on mastering. And this is brain fuck.
Or PA, or any other ESOLang you care to name.
Yeah. So then we're going to go back to the first commenter saying, yes, but learning programming languages is only a very small part of mastering the profession of programming. And the smaller, the better, unless it actually makes a visible difference in the quality of the programs produced. I can see taking years to learn the art of user interface design, and I can see spending 3 months every 2 years becoming acquainted with the new hardware and its capabilities, and I can see and approve endless learning about algorithms and data structures, but I can see that a professional programmer who has instead spent the equivalent amount of time becoming a master of COBOL, PLI, and ADA is really much ornamental to her profession. So essentially, what this first commentary is saying is that learning, the reason that he wants the languages to be small is because you have so much else to do and to learn that you don't want to spend all of that time with just the language. And that's very fair to say. But as Gabriel will say as well, that's kind of like very hard to make the distinction because this comment is kind of implying that learning the language is separate than learning the algorithms and the data structures. But then the question becomes, what are you programming that you're not using both of those things? So
That's very, yeah, that
how
is
can
a
you make that
problem.
detachment? Um, yeah, so it's hard for me to see how a language can be mastered outside of many of the activities he mentioned. Um, how can one possibly master a programming language without programming? And how can one program without learning about data structures, algorithms, and stuff like that? Then we go back to the whole architect analogy. Um, because, well, it's kind of like a parallel in here because you also have drawing skills on being an architect, which is one skill that you have to master. But part of your effort is in mastering the language of your profession, but this is hidden beneath the fabric of learning the facts and the techniques of that profession. But drawing is not only the only language of architecture. Those who study only design and not pattern languages are not in general capable of doing their jobs as well as they might. Another way to put this is that architects fail when they ignore the task of becoming masters of the languages they need to master. Then you go to the English example, which is that you may know English, but only when you study very hard subjects for many years is when Gabriel um, classified himself as having mastery on it. Even though he learned since sixth grade English, he only mastered 30 years later. And then you go to the example of software documentation, which is just hilarious because the ideal world is that we want the documentation to be done by an excellent writer. And then the second best way is to actually have an excellent writer interview a developer and or start with notes written by a developer. The third best way is to have a developer to write it. And then finally, the worst option would be an excellent writer with no knowledge of the topics at all. And the last two are bad. One wouldn't make much sense, and the other would not tell me much. Hard to guess, really, which would be worse. This supports partially the remark by the commenter that knowledge of the area is important, that knowing only how to write is not nearly enough. But the two best alternatives require good writers, so skill and mastery of writing in English do count for something. So we are basically seeing that learning something with the definition of getting it done and having a mastery on that something matters. This distinction actually matters for the final quality of the artifact.
Well, yes.
Um, when we think about applying this lesson to programming languages, the best alternative is an excellent designer, which, disclaimer, a great developer who doesn't necessarily know the programming language very well, who is also a master of the programming language. The next best thing is a great designer along with a language master. The third best is a great designer only, and the worst is a language master. And this actually makes a ton of sense, right? So, in the experience of making software, it's very common to talk to Well, I'm not gonna say common, but it's not a miracle to talk to someone that has a great design in mind, regardless of the tool that you're gonna build in the thing, And it's even in that, and it is rare to find someone that is good at both things. So you know you're a master of the language and a master of the design, the ability to make good, great designs. And I also agree that having a third, the great designer as the third best, is definitely better than just having a language master.
Yeah, because if you just have a language master who doesn't know how to design stuff, um, that sounds like a recipe for very esoteric code that doesn't actually do anything.
Or well, or a code that in order to be maintained is a hell, and you like to add a button on a web page, you need like 2 weeks.
Yeah, yeah.
Um, the real question we need to answer is whether such code can be more easily written in a small language, and we cannot really know the answer to this without scientific studies. Well, again, putting in questioning the whole idea that it is there is an obvious relationship about all of these very complicated questions and the size of the language. And then English provides an example of this scientific study that we are looking for in software, which is called Basic English, that unfortunately didn't move forward as far as my understanding goes. And Basic English is basically a subset of English that follows more strict rules. It stands for British American Scientific International and Commercial. These are the rules. Uh, these are the rules. And it's smaller than the English as a whole, of course. And even though it had support from Churchill and Roosevelt, it never made it forward. And here's an example. So in English, you would say, the final word on this was said by St. Augustine. What is time? He asked and replied, if no one asks me, I know. If I want to explain it to a questioner, I don't know. I do not know. And the same passage in Basic English is longer, more pedantic, but I would say um, this particular case, I think the trade-off is worth it because even though it's longer and less, well, more contorted, I don't find that to be too much up to the point of saying definitely no. This is still like, okay. So the statement which says
Hmm.
the most it is possible to say about it was made by St. Augustine. His answer to the question what is time was if no one puts the question to me, I am certain about it. If I have a mind to give a question an account of it, I am uncertain.
Uh, I'm not sure that I like this parallel between basic English and small languages. Because
Well,
this is assuming, like, the point of basic English is that you are basically saying, okay, let's restrict not just the vocabulary, but also how you can make abstractions in the language, right?
I
And
disagree. It's not doing that in my opinion. It is cutting the way the paths to make new abstractions because the only way to do that is compounding. Like imagine a Lisp. As far as my understanding goes, there are various types of Lisps that their only capabilities of making abstractions are functions and macros. Instead of two ways of making the abstractions, Basic English provides only one. You are
well,
on
if you're going to,
purpose making a stricter, more, the it's what I said about that Jonathan said. You are making something more strict. In this case, not because you want to prove properties about it, but because you want to make them composable, so you can put stuff on top of it. But you're only allowing the composability to be done in some particular ways. It's very specified ways.
uh, well, there are two problems with that. First of all, actually, the most expressive Lisps are Fexper based, and they have even less ways of making abstractions than functions and macros.
Okay.
And yet they are more expressive because, well, macros are not first class, but Fexpers are. So you can pass them around as arguments and put them in data
I think
structures. You
I
can't do
think
that
I
with a
think you
macro.
said something that is the key point. We are not cutting your expressiveness by using basic English. We're not cutting that at all. You
But
are capable of expressing the same. It is just small words, and you have to follow more rules, and you have less ways of doing
the,
the same thing. It's kind of like
uh,
the goal philosophy, the goal length
the
philosophy.
problem, no, the problem I'm trying to get at is okay. There are more ways of abstracting in English than just compounding words.
Sure,
Okay, you
sure,
can compound morphemes to create new words.
sure. What's the problem?
Basic English doesn't let you do that.
But but that's the idea. They wanted to make an experiment that are cutting your ways of making new abstractions and limiting to only one. How is that
This is
different
like
than a Lisp that limits me to functions and macros?
this is like saying, okay, if let me tweak the parallel a little bit to see if I can get my point across. If we compare normal English to a Lisp with functions and macros, this would be like this basic English would be like a Lisp with only macros, no functions.
Sure. Yeah, sure.
And that's a
I
problem because
100%
macros
know that people want that.
and that's a problem because macros are not first class. There are things you can do with functions that you can't do with macros.
No, but in that particular case, okay, but that's a little bit unfair because you're saying that, oh, in this particular Lisp that we're doing, macros are not first class. In this particular
No, no, no,
language, X is not
no,
first
no.
class. Doesn't matter.
Macros by definition are not first class.
No, I understand that in our case that we are constrained to Lisps and everything, there are some limitations to this analogy. I'm not saying like, okay, I'm just saying that if you have any technology and you want to make programming as a technology smaller, a lot of people suggest that you should not have many ways of doing the same thing. You should be restricted by design to have only a couple of options to doing your abstractions on top of. I just use macros and functions as an example. But the point, abstracting all of the details from Lisp aside, is people want to only have a couple of ways of making new abstractions. They don't want you to give you 5 or 10 ways of doing it. They see as a benefit, as a plus, as a feature, not a bug, to give you only two or only one way of doing that.
You I agree, but you still didn't get my point, I don't think.
No, I got your point. You're saying that in this particular example of the Lisp with macros and functions, this doesn't follow because macros are not first class, which means that there are things that only functions would be able to do and macros will not. So you are losing expressiveness in that case, and I agree. What I am saying, however, is that as far as my understanding goes, this example of basic English is not touching on the expressiveness side. It's just worse to communicate with it if you are using something that would be highly convenient to do in normal English, such as using other abstraction ways or like metaphors and personification and all
Let me try
that.
to let me try to put it a different way. It would be literally impossible to write Alice in Wonderland in basic English.
I don't know about that, actually.
Jabberwocky was a completely new word. It didn't exist before Alice in Wonderland.
Just swap that with nonsense. The word nonsense. And the character said nonsense. It's gonna be worse because
But Jabberwocky is not nonsense. You don't really know the exact meaning because it's a new word, but there's context around it. You can infer some meaning. It's something.
no, yeah. In the case of like fiction, that you have uh, ways of using the language to make new words and making new meanings, right? I kind of understand what you're saying. And in that particular case of there's no way to be literal about this. We need to use metaphors. We need to create new words. Otherwise, there's no way. It's impossible. Fine. That's not the example given here.
And I'm not complaining about the example, I'm complaining about the parallel he's trying to draw.
Okay, so you're complaining precisely that um, although in this particular example, writing something in English and in Basic English, it's very clear that Basic English is worse in terms of being more contorted, uglier, more convoluted in this case, longer, and in this case also a little harder. You were saying that because Basic English is less expressive. Wait, but then that's an argument in favor of being larger.
No, it's an argument in favor of picking your primitives more carefully.
That's also fair to say. That's also fair to say. What's the criteria to do that, though?
I'm not entirely sure, to be honest. Otherwise, if I were, I would be a language design master rather than a neophyte.
Um, well, okay, I got your point now. You're basically the overall end of the story of your point is Basic English is not as expressive as English because you cannot use certain language features given the limitations. And in your opinion, you would have a more useful Basic English if you can probably tweak those rules to be something else.
Essentially, yes. Although, to
Okay.
be honest, I wouldn't be interested in creating a basic English per se because, well, English is a natural language, right?
Well, but the principle is the same. We are trying to make this less diverse.
Yes, I would be more inclined to make something like Tokipona.
I don't know that, but okay.
It's a constructed language.
Okay. Well, but in my experience, now going back to programming, every time I had to go through a Lisp code base, I spent more time trying to find how people are doing stuff because there were many, 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 many indirections and many, many longer thingies to read because the capabilities of the language are by design it's one to three ways of doing the same thing. So if they choose, okay, let's just make a pile of 50 functions in a row, and I want to know what happens in the first function call, I'm going to have to go back all to that. Um, Instead of having a separate mechanism enlarging the language that does that in a single place. Which again, I'm not saying this is a clear victory for either side. I'm just saying my experience because I complained about this specifically when I was we were doing the Common Lisp game, and I found that pretty annoying back in the day. But you can also say that this can be solved via documentation. But well,
Common
document.
Lisp in particular is a bit sad because, well, it's a Common Lisp. It's a language designed by a committee, right? Uh, it kind of needs to be able to do the same thing in many different ways because it's trying to unify several different Lisp dialects.
Yeah, but that was not my case. My case was completely the opposite. It was just a bunch of macros and functions. The only
Okay.
problem is that there were long stack trays on that.
Okay.
Uh, the convolution is a little bit personal because you are probably used to reading a bunch of Lisp code that is using a bunch of Evolve shit. So for you, what's convoluted to me may not be convoluted to you, and vice versa.
Actually, it's not common style in Lisps that don't have experts to use eval. Like if your Lisp has macros, normally the first thing you learn is don't use eval directly.
Yeah, I also heard that before, but it was doing a bunch of like commas and tildes and all of that. And until I got the hang of it, to me it was very convoluted to do that.
Well, it is convoluted. Quotation is actually kind of a problem from a language design perspective.
Yeah. Well, continuing, now that we clarified your valid critique, someone who has learned a small language is generally familiar with almost all of its constructs and can therefore read most of the programs written in that language. Someone who has spent an equal amount of time learning a large language has only a passive and sketchy knowledge of many of its constructs and have a harder time understanding many programs because they use unfamiliar parts of the language. Hence, programs written in a small language are often more easily maintained and ported. And I think this is factual. I don't think you can. I don't see how you can counter argument this because this is like an objective deduction here. For example, if you're using Haskell or Rust, there will probably be, like a very advanced program, features of the language that you don't yet understand properly or fully, and you're gonna have to rely on copy pasting from places that you know it works. And you have many examples of this in Haskell, such as type families and lenses and typable type class, and what else have I seen? Um, I think if you go over typable, probably there's something sus going on because typable is already cursed. You should definitely think twice instead of using that. But this is definitely true of like you get some, you lose some. This is also the Go argument, right? Golang is proud to say that if you pick a program that is 15 years old in Go, today you can probably still read it and know what it does because there's only one or two ways of doing the same thing in Go. But of course, this goes back to being longer because now the Go is a very boilerplatey language, and part of the reason is because they don't want to change the things. They want to stick around with the heterocompatible reliability argument, which means that
Ah,
it's a bunch of function calls with ifs on new all the time.
that's kind of a silly argument because if you pick like a 10-year-old Clojure program and throw it at the current version of the Clojure compiler, it still works and it still does the same thing. And yet, Clojure is like orders of magnitude probably more expressive than Go.
Um,
So like I don't think backwards compatibility is a good argument in this case.
Yeah, but it's a dynamic language. Like there's so many extra differences between the two languages that it's very hard to make the comparison that you're trying to make. I also
I'm just
think a
trying
language that allows you to have macros put another layer of difference in that. Uh,
I'm just trying to say like okay, if you're going to argue from backwards compatibility and readability of old code, well, first of all, functional languages have you beat because lambda calculus, uh, it's a very common, very tiny core that if you learn it in one place, you can even bring it to other language and it will still be a valid way of understanding. Um, because of immutability, things don't generally break for no reason, right? And if you are used to working with immutability inside of the language, you are less likely, just because you're used to immutability, to make breaking changes in the language rules. Although that does take discipline, so not every functional language will work
yeah, no. If you
well.
put all of those premises that I like in place, I think we're gonna get to a conclusion that yeah, you gain the retrocompatible code as a bonus, or as a like a consequence of those premises. But I'm talking about like C++ and Go and like static languages that don't use those premises that you just described as foundation. So as far as my understanding goes, Go is trying to achieve retrocompatible code in a static language with no metaprogramming since 15 years ago, and that is the reason that they avoided doing generics for so long. Because they knew that at the point that you introduce that and you don't have, um, for the lack of a better word, you decided to do ad hoc foundation, uh, that's hard. Yeah, that makes sense. That follows.
I
Uh,
mean, that's a problem with doing an ad hoc foundation, not with generics per
no,
se,
no.
right?
I'm saying that it's given that you chose to do the foundation like that. Yes, it is hard.
Uh, Zig is not an example right now because the language hasn't really hit 1.0 yet. I expect this will be a long-term goal of the language, but like after it hits 1.0 and the language does will be stable and all that, I expect it probably have good backwards compatibility. Right now it clearly doesn't, right? Because things break between versions all the time.
But I actually
Uh,
don't know. How can I say? This is also this is not written in the book, but I also think that's something that the small languages have as a plus because you are so small, you know very immediately what change will break what. It's not like, oh, I need a test suite of like 5,000 tests because I'm not really sure that adding this new syntax will break pattern matching or type classes or type families or these and that and that and that extension.
yeah,
Uh,
exactly.
that is a
And
plus of small languages. Which again, I do believe, especially reading this chapter, that this is not a very easy debate. However, it comes. Um, you can fuck it up. That's basically my point. If you have a small language, but you're not really putting making a stance on the foundation, it can still be hard.
Yeah, like the reason I brought up Zig in particular as a contrast to Go is that Zig is also a small language. It is deliberately trying to be a small language because C is a small language and it's trying to like usurp C as the best low-level language around, right?
Yeah.
But like Go, they they stayed away from generics for a long time because ad hoc foundations they things are hard, right?
Yeah,
Zig
that's
is
what I
the
heard.
opposite. Zig is the opposite. Like Andrew Kelly was not intending to add generics to the language, but they just fell out of the design of okay, you have comp time, types are first class values, therefore you have generics. Like he kind of got generics by accident because his foundation was solid.
Yeah, but although I haven't played with the whole interfaces that you mentioned to me, but I classify Ziggs and generics as like halfway. I still want something that resembles type classes. Aside from like we used some of that in Raylib, but that was just a coincidence that there was a function for each particular type of the assets that had the same name, and then we could exploit that for like 3 or 4 types of assets. But at the point that we had to do music or 3D models, we couldn't. And I
But
think that
well,
sucks.
yeah, well, the canonical example of an interface is actually the allocator interface in Zig.
Well, again, the way that I understand that I used Z generics in Lyceum with you is I classify that as like halfway there. I still want something that resembles modules in ML or type classes in Haskell or traits in Rust. But I do understand if they say that's too much, we don't want to go over there for efficiency reasons or community reasons or whatever reasons, like if the reasons are reasonable. I can understand. It is just that I felt the need that, man, that would be very useful right now, and we don't have that. But anyway, so continue here. Now we're going to go to another quote, which is small languages tend to be better designed than large languages, showing fewer signs of ad hoc compromise between conflicting aesthetics, principles, and design goals. And then we go back to the whole idea people don't care about design goals and aesthetics because it's not how they usually do programming. And uh, Gabriel classifies this more of a reflecting mathematical or abstract considerations of Luckman, no hand, single mechanism trickery. We cannot deny, however, that a small set of principles and goals applied to design as one language usually results in a consistent, concise language. So he's kind of making like this is not what people intend to do, but they kind of get it by consequence. And I think that's I think we should have design goals. I think the tool should be very specific about what's its purpose and how it's best utilized. And that usually comes from a more mathematical goal of doing things. And that ends up with a more consistent and concise language, at least in the beginning. It may diverge later. Um, so large languages cannot be as consistent as small ones. Large languages necessarily address more problems, and it makes sense to do this only if those problems vary. With a small language with a large class library, so Smalltalk is an example, we have exactly the same problem. The success of Smalltalk is due to the consistent and careful design of those class libraries coupled with a uniform access technique, message passing, so it's not a surprise that most libraries are designed by the same people that designed the language itself. Um, and then we go to another quote, which is programming language should be designed not by piling feature on top of feature, but by removing the weaknesses and restrictions that make additional features appear necessary. Scheme demonstrates that a very small number of rules for forming expressions, with no restrictions on how they are composed, suffice to form a practical and efficient programming language that is flexible enough to support most of the major programming paradigms in use today. And
Yeah, he brings
this
up continuations, of course.
Yeah, yeah, no, but that's a very interesting point, which is that if you follow this principle, you may achieve greater power, but that comes with uh, the bar to use it safely and makes programs comprehensible. The bar gets higher. So you the core is small and it's still powerful and expressive enough, but that comes with a trade-off of like, okay, now not everyone can do this properly. Now only a subset of people can actually utilize this power, like with great power comes great responsibility type of thing, to do it properly. And then we have the call with current continuation, which essentially limits the possibility of knowing how many times a statement is executed, unless all the code in the program is available for inspection. And that can go bad with the presence of side effects, of course. So yeah, so things can get very unsafe and incomprehensible if you know what you're doing. But well, this is again something that people can improve and learn on. So what do you want? You either want a tool that is best fit for the current version of people, the current version of developers, and that goes back to the average problem. What if the average is crap? Or you make the tool properly and you make a bet that people will somehow be forced to learn it. Which, well, I don't think people will do that bet because, well, that's very bold. Uh, so now we're going to go through statements that are incorrect, but there's some truth to them. Small programs are better than large programs because small programs fit a fewer diskettes, which cost less pottage to mail and take less time to feed into the diskette drive. Small languages are better than large languages because small languages produce small programs and large programs produce large programs. This last part is just like, have you ever did programming, my friend? That's not how things work.
Yeah, no, that's just wrong.
The most important aspect of product development is to time to market. Large languages are better than small languages because large languages allow products to be developed more quickly since they contain more reusable components. That depends on who is using the large languages. If they are using it properly, if they have a bunch of senior developers, yeah, maybe. If they are not
Uh,
senior developers, who is going to tell them which reusable components to use? So,
yeah,
because with a small language,
JavaScript.
you have less reusable components. You have fewer choices. So you
Yeah,
can only guess wrong so many times.
yeah,
JavaScript, you're
yeah.
saying?
JavaScript comes to mind because at this point it's kind of a big language. Um, like the older versions of JavaScript were pretty small. They had a very tight core, although that core is not particularly well designed. It did have a small core,
Hmm.
but like it grew over time with new standards and stuff. And it's like, dude, are you really like if you just look at JavaScript code in the wild, like yeah,
Sure.
it's just very sad.
And then we go back to the same argument but opposite. So small languages are better than large languages because small languages allow products to be developed more quickly since it doesn't require as much time to learn all the reusable components. And I think both of these versions can be true, but they have so many depends that I don't know if it's useful to list them. The above arguments assume the library is part of the language, as do most of the scheme versus common Lisp arguments. If you grant that the library is part of the language and the library includes such things as the user interface toolbox, then there is no such thing as a series of small language today. If you look only at the core languages on libraries, the size of the core language has more to do with elegance perceived by language connoisseurs than the size or time to market of delivered applications. A small core language probably does lead on the average to easier compatibility and a higher quality of implementation, although the size of the core is just one of the many forces affecting those qualities. And I'm not joking, essentially. So it isn't clear right away whether using a library will hurt or help the speed of development. It is not just learning their usable components, but also adapting the code that uses them. And we saw this earlier. Uh, if a module is rigidly defined,
Defined.
the code that uses it must be written so that it can be used as is. If the door you bought is 2 feet wide and then 10 feet high, it is what it is.
I
Furthermore,
mean, you can technically cut the door, right? It's probably made of wood, but then you
uh,
can't make it any larger. So there's that.
furthermore, good luck if there is a problem inside one of those components. A problem is not necessarily a bug. It just not does what you want to do. And there is some difference in effectiveness or usefulness between a small and large programming language, and we need scientific studies to tells us what they are. No amount of reasoning from first principles can inform it half as well as can a few carefully done studies. I would say that experience also tells a big role in this.
This is hard, right? Because if you think about it, a programming language is also a user interface, and reasoning from first principles about user interfaces, well, anything really that has any elements of human interaction is pretty difficult, like just intrinsically.
But I think that's a solvable problem. I think this goes back to the whole adaptability argument because, again, especially the next chapter where we're going to talk about the rules of how to get a language su- to succeed instead of fail. I think all of this analysis is pretty much static all the way through. So like he's analyzing how things went and how things are, and he's not considering that people may change. He's assuming that it is what it is and it is what it isn't what it isn't. And I think the problem is that the only way to fix all of these things is to put objective measures on top of it. Because you either do that or you're gonna have to do a bunch of ad hoc stuff and people may be mad at you. So, for example, you need to establish that if you're gonna go with the more mathematical route, and which we're gonna next chapter, next time we're gonna talk about, you need to accept the reality that your target audience is the mathematical people. You cannot not accept that reality because if you do, people that are not mathematicians will be mad at you that you are using a premise that they disagree. But you are establishing that from upfront. You are not like trying to satisfy everyone. That's the point. I think that's the solution to this problem. If you say in the beginning that it's gonna be small and the only three mechanisms are gonna be this, and that, you need to eat the cost of you may fail because next chapter will
Well,
explain that there are some rules to this game, but you
yeah,
at least can uh, dodge this problem of like, is this language small or large or whatever. Of course, you're gonna have to also define if the library is gonna be a must-have to your language or not. How much useful the core will be if it's gonna be small. That's a very good question.
it is indeed.
But I think you can dodge this by establishing upfront some premises. You may change your mind. Jonathan said that he's not really certain he's going to be able to deliver on one of the promises of Jai. He said Jai was supposed to be a simple language, and in one of his interviews from 3 months ago, he's not really sure that's the case anymore. But that's a good thing that his language is closed. He still can make that decision of like, I promised something in the beginning, it ended up different than what I said, but it's fine because nobody's this language doesn't exist open source. So you still can have the time to change your mind.
Yeah, that is actually an advantage of his approach.
So yeah, but this conversation I think it's useful because I think at least my previous self, when we had that conversation about small languages and big languages last time, to me, I didn't think about some of these points like, man, if I need to use the library every time I use the language, is this really small then? I don't know. The whole idea that this contrast of properties between large and small, I also think it's very productive. So yeah, that's it for this chapter. Anything else?
Ah, well, if nothing else, this is a really interesting chapter.
Yeah, no,
Like,
this is very good. I really like. I bet like I was very sure that man Marinho will like this chapter because this talks about what he likes to talk about.
yeah, it's like it's very thought provoking.
Okay, I agree. I'm gonna finish the recording now.